Hello everybody, welcome into another lesson. So today we are going to do first of a three-part series of systems of quadratic equations. And in today's lesson we are going to find the intersection of a quadratic and a linear equation. In other words, what we're geometrically trying to figure out is where do a conic section and a line intersect. In this particular case, we have the equation of a parabola and the equation of a line. So we want to figure out where do a parabola and a line intersect. So you have x squared minus y equals 5, and then negative 3x minus y equals negative 7. Now, when we solved original systems of equations when everything was linear, we either used substitution or elimination. Well, we can really use a lot of the same tricks even in quadratic systems. So it looks like we can eliminate the y variable if we subtract the second equation from the first, right? So if we do that, you'll get x squared minus 3x. This would turn into x squared plus 3x. And then negative y minus negative y, well, that'll cancel out the y. And 5 minus 7, that'll turn into 5 plus 7, which is 12. So now you're down to a simple quadratic equation. So you have x squared plus 3x equals 12. As we know then, this would be x squared plus 3x minus 12 equals 0. So it doesn't look like it's going to factor nicely, so let's do the quadratic formula here. So we have x equals the negative of 3 plus and minus the square root of 3 squared minus 4 times that 1 times that negative 12 all over 2, which would simplify into negative 3 plus and minus the square root of 9 plus 48 over 2, which would give you negative 3 plus and minus the square root of 57 over 2. And those are your solutions for x. But we're going to, since we have two solutions for x, we're actually going to have two solutions for y. Now, I could put this in here into either equation. I'm definitely going to suggest putting this into the linear equation. So if I do that, then, so if I take negative 3x minus y equals negative 7, well, that would simply then give me that y equals 3x. Yeah, I could get, let's see, I think I'm doing that backwards. Yeah, y equals negative 3x plus 7. So then you just put in each solution for x. So y, let's see, would equal negative 3 times negative 3 plus and minus the square root of 57 all over 2 plus 7. Which, if we can simplify this, that's going to equal then 9 plus and minus 3 times the square root of 57 all over 2. Then you have that plus 7, which would be plus 14 over 2. So this turns into a hot mess here. That means the x will be the original -3 plus and minus the square root of 57 over 2. Your y will have a coordinate of 23 plus and minus 3 times the square root of 57 all over 2. So your parabola and line intersect at 2 points, depending upon where your plus and minus are. The points of intersection are -3 plus and minus the square root of 57 over 2 for your x, and then 23 plus and minus 3 times the square root of 57 over 2 for your y. So as you see, you get some not so pretty answers sometimes, but this is where the parabola and the line intersect. Now let's do something. Let's do another type of conic in a line. Alright, so we have x squared plus y squared equals 7. Then we're given that y equals x minus 7. So here, this is clearly a circle in a line. We're going to try to figure out where a circle and a line intersect. So this is definitely going to be solved by substitution. You'll put the x minus 7 in for y. So this would turn into x squared plus the quantity of x minus 7 squared equals 7. So you'll get x squared plus x squared minus 14x plus 49 equals 7. So this would turn into 2x squared minus 14x plus 42 equals 0. Let me get a different black marker. That might help. I probably prefer to do that, honestly. Get a different black marker. There we go. So you factor this. You can factor out a common 2 from this quadratic equation, dropping it down to x squared minus 7x plus 21 is equal to 0. And guess what? We have another not so pretty equation. So this is going to be another quadratic. So x equals the negative of b, which would actually be positive 7, plus and minus the square root of that negative 7 squared minus 4 times that 1 times positive 21 all over 2, which would give you 7 plus and minus the square root of 49 minus 84 over 2. Well, here's the thing. Underneath a radical, you have 49 minus 84. That'll give you a negative 35, which is imaginary. So we actually have no real solution. We have no real solution to this. So in other words, in this case, the line and the circle do not intersect whatsoever. So there's no real solution to this one. Now, if it would have intersected at only one point, you could actually argue it's a tangent line, because tangent lines only touch the circle at one point. If it would have intersected at 2 points, then you would have had 2 coordinates. That would have actually been what's called a secant line. Now, what if I do another circle? We have x squared plus y squared equals 1. We have x plus y equals -1. So another circle and another line. But, you know, I'm honestly going to suggest we solve this by substitution, since one equation is completely quadratic and one's completely linear. In this case, I think we'll still substitute for y. So we could make y equal to -x minus 1. So now substitute that into your first equation. You'll have x squared plus that -x minus 1 squared equal to 1. So you'll get x squared plus x squared. Multiply it, you'll get plus 2x plus 1 is equal to 1, which would simply give you 2x squared plus 2x equals 0. And then you can factor out a common 2x, so you'll get 2x times x plus 1 equals 0. And then, of course, x equals 0 and x equals -1. So you have two solutions for x. That means you're going to have two solutions for y. So when x is 0, let's find your first y. Put in 0 for x, you would get -1. So your first point of intersection is going to be at 0, -1. And then we'll find your second y, put in -1 is actually +1 minus 1. You would get 0. So your second point is going to be at -1, 0. So the circle and the line intersect at actually 2 points at 0, -1 and -1, 0. Well, you have actually then a secant line since they intersect at 2 points. Alright, I got a couple more and that's it. This isn't going to be a very long lesson because linear intersections are relatively straightforward. Alright. We have y squared minus 2x squared is equal to 6. And then they give you that y equals -2x. So here we have the equation of a hyperbola and a line. We got to figure out where a hyperbola and a line intersect. Again, I'm going to say do substitution. Put that -2x in for y. So this will turn into -2x squared minus 2x squared equals 6. So you'll end up then getting positive 4x squared minus 2x squared equals 6, which would then give you that 2x squared equals 6, giving you x squared equals 3. So x would equal both plus and minus the square root of 3. So you have two coordinates for x, which means you'll have two coordinates for y. So you just put those x values in, you'll end up getting, so let's see, y would equal -2 times plus and minus the square root of 3. So what you'll get is that y equals, then you could either, if y is positive, if the x is positive square root of 3, you'll get y equals -2 times the square root of 3. And then if square root of 3 is negative, you'll end up getting positive 2 times the square root of 3. So your points of intersection are going to end up being the square root of 3 negative 2 times the square root of 3, and then you'll end up having negative square root of 3 positive 2 times the square root of 3. These are the 2 points where the hyperbola and the line intersect at square root of 3, negative 2 times the square root of 3, negative square root of 3, positive 2 times the square root of 3. And I got just one more, then we're done. Alright, we have 6x squared plus 3y squared equals 12. Y equals negative x plus 2. Alright, so we have 6x squared plus 3y squared equals 12. Y equals negative x plus 2. So the top equation this time is the equation of an ellipse and then a line. So we want to figure out where do the ellipse and the line intersect. Again, this will largely be solved by substitution, and most of these are, but every once in a while, if you have a parabola on a line, you can use elimination. But the rest of these are always solved by substitution. So substitute that negative x plus 2 in for y. So you'll take 6x squared plus 3 times negative x plus 2 to the quantity squared is equal to 12. So then this will turn into 6x squared plus 3 times x squared minus 4x plus 4 is equal to 12. So you would get 6x squared plus 3x squared minus 12x plus 12 equals 12. So this would turn into 9x squared minus 12x equals 0. So this turns into something a lot simpler. Well, you can definitely factor out a common 3x, right? If you do that, you'll get 3x times 3x minus 4 equals 0. Well, 3x equal to 0, that'll give you x equals 0. Then 3x minus 4, so that gives you 3x equals 4, which x would equal 4/3. So you have two x coordinates for the point of intersection. That means you're going to have two y's. So let's find the first y. We'll put in 0 for x, so negative of 0 plus 2, which would just give you 2. So your first point of intersection will be at 0, 2, but there's one more since you have a second y coordinate. Your second y coordinate will be that negative 4/3 plus 2, which would really end up giving you positive 2/3. So your second point of intersection is going to be 4/3, 2/3. So the ellipse and the line intersect at the points 0, 2, and then 4/3, 2/3. Those are your 2 points of intersection. So that's it for this lesson. Next lesson we are going to do part 2 of systems of quadratic equations. This time it'll be the intersection of two conic sections. So I hope everyone has a great day. Take care.